Hello everyone, welcome to another lesson in the Python Programming for Beginners series, where we'll be taking a look into error handling in Python programming language using the try except block. Understanding how to manage errors is crucial for writing programs in every programming language, not only Python now. And Python gives us a powerful tool to handle exceptions with ease. But before we jump right into try except, let's first understand what exceptions are. You see, in Python programming language, an exception is an error that occurs during the execution of a program. Where Python encounters an error, it traces an exception, which can interrupt the normal flow of the program. In our common words, we say that the program has crashed. So whenever Python encounters an error, it traces an exception, and that exception is going to cause an interruption in the flow of the program, which is going to cause the program to crash. Some of the common errors that we've encountered in the course of this series, we've encountered the name error exception, we've encountered a syntax error, we've encountered what other exception have we encountered? We've encountered indentation error. We've also encountered value error. So there are various exceptions like that Python raised whenever it encounters an error in the execution of your program. Python offers the try except blocks to catch and handle these exceptions and allow your program to run smoothly even when errors occur. Alright, before we start working with try and except block, I want us to illustrate a simple code that is going to run into error. So, for example, we have a variable with the name of number, and you are getting number as an input from your user, so you use the input function, and then you can tell your user to enter a number. Okay, so you are getting this as input from your user. But by default, you know that the input function is going to return string, so to convert that to integer, you use the int function. Alright. Okay, so here we are going to perform a basic multiplication operation. So you can call this product, so you can say product is number, and also multiply it by any number. Let's multiply it by 5. Okay, so now we can print product. Print should invoke the print function, then product. If you run this code now, let's run this and see what we have. We are going to have a prompt in our console that is telling us to input a number. So you can as well input a number 5, or you can input any number. You can input 10. So with this now, this int function is going to turn this into integer, and our program is going to run smoothly. But here we want to illustrate an error. We want to illustrate an exception. So if we use keyword for a number, let's say 10. So if we run this now, we are going to run into value error. So you can see invalid literal for ints with base 10. This is a simple example of codes that can run into error. So in cases like this, whenever Python run into error, it is going to raise an exception. So in this case, the exception that was raised is the value error. These are the situations where try and except block are needful to handle all these errors, so that your program is not going to crash like this. You are going to handle this error, and your program is going to continue running dependent on how you handle the error. So to handle errors like this, Python provides the try except block to handle this type of cases. So to use that, we can put this in a try except block. So you can come to the beginning here, and then you define your try except block. Here you can say try. You have the try keyword. Then you are going to indent your code. The code that you know has the possibility of running into error that is going to cause an exception, you write them in the try block. So whatever error you want to undo, you undo it in the except part of the block. So you have the except keyword followed by whatever error you want to undo. So we have name error, you have zero division error, you have indentation error, you have syntax error, you have various types of error. But in cases like this, the possible error that can be raised in this kind of situation is value error. So you have except followed by the error you want to undo. This is going to be value error. So you have your colon, Then inside of the except block, you are going to perform whatever operation you want to perform anytime this kind of exception is raised. So here you can say, you can print to the console, and then you can pass an information to the user that please enter a valid integer. All right, so let's run this again now and see the difference and when we have a try except handling and when we don't. So let's say we have 10 again now, just like the previous time. If I enter this now, so instead of the program to crash, the exception has been handled in this part of the code. So you see, please enter a valid integer, and the program ended gracefully without crashing. So whenever you want to use try except block to undo errors, you have the try keyword, and inside of the try block, this is where you write all the code that you know that has the potential of running into error. So whatever error you want to undo, possibly syntax error, indentation error, zero division error, whatever error you want to undo, you provide the error here. Then inside of the except block, you are going to write whatever code that you want to execute whenever an exception is raised. Sometimes different parts of your code can raise different exceptions. You can also undo multiple exceptions using multiple except blocks. For example, you want to perform a division operation. So instead of calling this product, we can call it, let's say, div for division operation. So you can say number divided by 5. Okay, so we are going to be printing div. Okay, so let's say we want to divide 20 by whatever number the user provides. So you can say 20 divided by number. Number is the value we are getting from our user. So in cases like this, let's run this code again and see. Okay, now we have the prompt enter a number to the user. So for example, if the user provides 0 as the number, so you see, we run into zero division error, which has not been handled in the try and except block. What was handled here is value error, and this exception is going to be triggered only when we run into value error. So what happens when we have another error that is raised during the execution of the code? So to handle that, you use multiple except block, and to do that, you can as well have another except keyword here. So you have except followed by the error you want to undo. So here we want to undo zero division error, and then you have your colon. So inside of this except block, this is where you are going to write the code that is going to be executed whenever zero division error is raised. So you can as well print, so you can pass the message to the user that division by 0 is not allowed. Okay, so this is how you undo multiple exceptions using try except block. You can have multiple exceptions in the same try and except block. So each of the exceptions is going to undo respective errors, respective exceptions that are raised by Python. You can also cache multiple exceptions in a single except block. How do you do that? Unlike now we have different except blocks for different exceptions. Here we have this except block for value error, we have this except block for zero division error. You can as well combine multiple exceptions in the same except block. How do you do that? So you are going to write your exceptions in a bracket. We can comment this out so you have this for reference for multiple exceptions, and we can as well, okay, before we comment it out, let's copy this. So you can have except. Okay, so we are going to clear this out since we want to undo all the exceptions in a single except block. So what we are going to do is we write this in a bracket, in a parenthesis. We have value error, and you can then provide as many exceptions you want to undo in this block. So you can have zero division error. Okay, then you use the ask keyword, and then you can call all of them whatever name you want to use to represent all the errors that can be raised. So we can call this error. Now we can print the error into the console. So we can have f string. So we can say error okay, to signify that an error has occurred. Then you can print the error. You have curly braces and then you have error. That is the name we use to represent all the possible errors that can occur. Now let's run this. So let's create a value error. We'll create that using a value that cannot be converted into integer. Let's use 2 now. We use 10 the other time. So you can see the error has been undo. So what was printed, you see error. That is what we wrote in our print function. You see error, invalid literal for ints with base 10. So what was provided was 2. This is how you undo multiple exceptions in a single except block. You write your exceptions, as many exceptions you want, you write them in a parenthesis, and then to be able to make reference to them, you use the as keyword. So you write the name that you want to use to represent all the errors that are raised. Okay, so what do we have next? We have the else clause. Okay, Python also provides an optional else clause that you can use to execute code whenever any exception is not raised during the execution of your code. Just like now that we have print, after performing this division operation, we can use else to run this code if any exception is not raised during the execution of this code in the try block. So the else block comes after the except blocks. So after you've written as many excepts you want to write, then you write your else. The else is used to execute code if no exception was raised. So you have else. So rather than printing this here, you can carry this into the else block. So you have print. Now if you run this now, if no exception was raised, then you are going to, after executing this, then you are going to jump into the else block. So let's say we have let's say 2. Okay, so we have 2 as the input. Then after getting the input from the user, the input is assigned to variable number. Then we divide 20 by number. After finishing executing the try block, no exception was raised, so we jump into the else block, and then in the else block you print the result of the division operation, which is what we have here as 10.0. And also we have the finally clause. Apart from the else clause, we also have the finally clause. Sometimes you want to execute code regardless of whether an exception occurred or not. Else is used to execute code if no exception was raised, but finally is used to execute code regardless of whether exception is raised or exception is not raised. So the finally clause, the finally block, is always executed either there is an exception or there is no exception. This finally block is mostly useful whenever you are establishing connections to remote server. Possibly you've established a connection to a database and you want to fetch data from the database. If you encountered an error during your data fetching or you don't encounter any error, so you always want to close your connection to the database after performing your operation. So that is a perfect use case for the finally clause. So we can come after the else block and then you write finally. So after in the finally block you can print, okay, you can say mathematical, let's say mathematical operation completed. Okay, this is just a simple illustration for finally block. You have better use case for it realistically. So if we run this now, even if we run into error, let's create an error. Let's use 0, which is going to create zero division error. So you have error, division by 0 is not allowed. Then you have mathematical operation completed. That is the function of the finally. You can as well raise exceptions. Apart from the built-in exceptions that can be raised by Python, built-in exceptions like name error, value error, syntax error, indentation error, and different exceptions like that. So apart from those, you can manually raise exceptions whenever you are designing your program. You raise exceptions using the raise keyword. So for example, let's have an example here. Let's comment this out. possibly you want to get the age of your user and you provide, let's say we have the try block. So you want to get the age of your user and you give the user prompt to provide his or her age, and the user is giving you a value that is less than 0. Normally no one can have an age that is less than 0, so you can manually raise an error in such case. So you can say age is a variable, and then you are getting an input from your user. Then you can say please enter your age. Okay, so you are saying the user should enter his or her age, and then you use the int function to turn that into integer. Okay, now you can check if age is less than 0. So then you can raise an exception using the raise keyword. Then you can raise, so you can say value error. Normally, even if your user provides a negative age, it's going to pass in the int function, but because the operation you want to perform cannot use any number that is less than 0 as age, so you can then manually raise the value error exception. And then you can pass the prompt age cannot be negative. Okay, now after raising the exception, you can create an except block to handle such exception. Then you have except, so you have value error, which is the error that you are anticipating just in case your user provide a value that is less than 0 as his or her age. Then here you can print the error. Print. Okay, so the value error you can give it error as a name so that you can make reference to it. So you have f string. Then you can say error. Then you can print the error. So you can say error, right? If you run this now, let's clear the console using the clear command. Okay, so let's run this. What do we have? We have please enter your age. If the user provides a value that is greater than 0, then nothing will happen because we will not undo any case of when the value is valid. So now let's check if the user provides a value that is less than 0. Let's say the user said his age is -20. So if we run this now, so after providing a negative number, the int function is going to pass it because -20 is actually a valid integer. But here in this conditional statement, you are checking if the value provided by the user is less than 0. So if the value is less than 0, then you raise this value error, and then you pass this prompt into your exception. So this except block caches the value error, and then you print the error, which is what is printed there. You see error, age cannot be negative. So that's that about try and except block. For now, we've taken into consideration most of the use cases of try and except block. So you write your code in the try block, and then you cache your exceptions in the except block. And in the else block, you write codes that should be executed. Peradventure, no exception was raised. And then use in the finally block, you perform operations that you need to be performed. Either an exception was raised or an exception was not raised. Okay, don't forget to subscribe to the channel. I will see you in the next lesson.